In this section, we are focused on a particular type of unit vector called the standard unit vector. Now, each space has different standard unit vectors. Generally, the standard unit vectors are going to be unit vectors pointing in the direction of the positive axes in that space. So let's start with an example. Let's look at R2. So let's consider two-dimensional space. Okay, so graphically, if we draw our axes here, our x and y axes, and let's say that's 1 unit, 2 units, 3 units, 1, 2, -1, -1, okay, something like that. Then our first standard unit vector in standard position is going to be the unit vector pointing in the direction of the positive x-axis. Okay, we call this vector I. We reserve letter I for this particular standard unit vector pointing in the positive x direction. And similarly, the unit vector pointing in the positive y direction is also a standard unit vector. It's vector j. And so these are the standard unit vectors in R2. So the standard unit vectors in R2 are I, and if we write I in component form, then we're moving in the positive x direction, and we're a unit vector, so the components will be 1, 0. So it has length 1, and it's pointing only in the positive x direction. And vector j, and the components of vector j are going to be 0, 1. So it's a unit vector, is length 1, and it's pointing in the positive y direction. We like the standard unit vectors because we can write all other vectors in R2 as a linear combination of vectors I and j. That's a term that's probably new to you, but linear combinations are going to be an idea that we come back to again and again. So let me show you what I mean. We can express every vector in R2 as a linear combination of I and j. So let's look at an example. Let's let vector v be the vector 3, 4 in R2. Then we can use our vector arithmetic to express v in a different way. Then v, which is 3, 4, what I'm going to do is I'm going to think about the first component of my vector and the second component of my vector and separate them. So I'm going to break it into a sum of two vectors, where the first vector, I only have the x component being non-zero. And the second vector, I only have the y component being non-zero. Now, certainly these are equivalent, right, by vector arithmetic. But now I'm able to focus only on the x component here. I'm able to focus separately on the y component here. And I could go even further, because now, since this is just 0, I can pull out a scalar multiple of 3 from this vector. Leaving me with the vector 1, 0. All right? using vector arithmetic, this is the same as this, right? But now I'm separating the magnitude of the change from the direction. And similarly here, I can pull out the 4 as a scalar multiple, leaving me with the vector 0, 1. And so now I'm looking separately at the magnitude of the vector and the direction of the vector. This is now a unit vector. And in particular, it's not just any unit vector, it is one of the standard unit vectors, right? 1, 0, 0, 1, those are our standard unit vectors. So I can write this as 3i plus 4j. And this is a linear combination of vectors I and j. Okay, we're going to talk more about linear combination, a lot more about linear combination later on in the course. It's going to be an idea we come back to again and again. It's an important idea in linear algebra. In short, in essence, it just means that a linear combination of vectors I and j means we have multiples of I and j being added to each other. So in this case, I have 3 times I have 4 times j, so those are multiples of I and j, and I'm just adding them together. Okay? So that's one example of a vector being expressed as a linear combination of vectors I and j, but we could do this same procedure with any vector. There's nothing special about vector v here. If I could do the same thing for any vector, notice that the multiples for I and j are the same as the components of v. And so this is just another way of writing vector v. There are some disciplines like physics that prefer this way of writing vectors. So just another way of expressing vectors, and sometimes it can be useful to think of vectors in this way.